So this is a quick video lesson on how to add forces. First up, we're going to work on adding linear forces. And by linear forces, I mean forces that follow the same line, like you could line up a ruler on them. So if you look here, we could go ahead and put a ruler right over these two forces, and they're going in the same direction, so those are linear, as are these forces down here. Even though they're going opposite direction, they're still linear. When we have linear forces, you can just add these like normal numbers, like you would on your fingers. So, in this particular case, when I want to find the net force for this first example, I'm just going to add 3 plus 4. So the net force here, remember net force is that funny looking E, F, right? This symbol here means net, total. And all I have to do is add 4 newtons plus 3 newtons, so the net force is 7 newtons. Or I could redraw this picture and say that the net force equals 7 newtons. Now, when you're looking at a picture like this, where you have two forces that are linear, but in opposite directions, you account for that opposite direction just by using negative signs. So, in this picture, instead of 3 plus 4, it is really going to be 4 newtons plus negative 3 newtons, or 4 minus 3 newtons, and that gives us plus 1 newton. Or the net force here is just 1 newton. Notice I'm using to the right as my positive direction and to the left as my negative direction, like we usually do. In this picture, the only difference is 4 newtons is now the negative number. So if I were to find the force, the net force that is, it would be negative 4 plus 3, or negative 1 newton. So if I were to draw the net force, it would look like this. 1 newton going to the left. This will work for any set of forces that are linear. If they're up and down, left and right, if they're sort of up and to the left and down and to the right, as long as they follow a straight line, like you could put a ruler on them. Things get a little more complicated when forces are perpendicular or not linear, like we have here. You cannot just add these forces. I cannot add 3 plus 4 and say that the net force is 7 newtons. It just isn't. If you imagine that these are two students pulling on something, so imagine there's a cookie right here, and students are pulling one person up and one person over. If you think about it intuitively, the cookie's going to go somewhere down the middle here. That dotted line would represent the net force. You already know this intuitively. You may not have done the math, but you know what would happen. So, in order to solve this problem mathematically, we need to use something called the Pythagorean theorem. You often see this in math class when you're studying triangles. What the Pythagorean theorem allows us to do is find a third side of a triangle if we know the other two sides, as long as they are perpendicular. So I've got two lines here, and I'm going to fill out the rest of this rectangle. You could sort of imagine that the 3 newtons and 4 newtons form two sides of a rectangle. Then I'm going to draw the diagonal line. I'll make it red. This red line represents the net force. We're doing something here called adding vectors. So really, my triangle could look like this. I have 4 newtons going this way. And you'll notice I'm going to move the 3 newton vector to this end. And the net force is going to be that length of a triangle. In geometry, you learn to call that the hypotenuse. This is where the Pythagorean theorem comes in. The Pythagorean theorem teaches us that the net force, if we square it, will equal the sum of the squares of the 2 sides of the triangle. In other words, if I take 3 newtons and square it, I'm going to get 9 newtons. And if I square 4 newtons, this should be squared, if I square 4 newtons, I get 16 newtons squared. It is important that you go in order when you do this problem, meaning I first want to square each of the forces. Now I can add them, and when I add 9 plus 16, I get 25 newtons squared, and that equals the square of the net force. To figure out what the net force is, I'm going to take the square root now of either side. And you can find this on your calculator. Basically, a square root, if you remember, undoes a square. And just like we do in other things in algebra, you have to take the square root of both sides. If I take the square root of the left side of the equation, I need to take the square root of the right side. And so I'm going to take the square root of both sides. Now, here's the good thing. The square root of 25 is just 5. And the square root of 25 is just 5. The square root of newton squared is newtons. And the square root of the net force squared is just the net force. Or, what I've learned here is the value of the net force in this problem is 5 newtons. I can do the same thing down here. 5 newtons and 12 newtons. Again, I'm going to draw out the sides to make this a rectangle. Doing so allows me to see that there's actually a triangle here. I'm going to actually make this a little bigger and draw the triangle, where this red line represents the net force. At the same time, when I draw out the sides of the triangle, I'm essentially copying this 5 newton force and putting it down here. You could say the same thing. I'm copying the 12 newton force and putting it over here. What this does is set us up for a new triangle. I have 12 newtons going down like this, 5 newtons going like that, and the hypotenuse, or the long side of the triangle, is the net force. So here's what I can do with that. Again, I'm going to set up the Pythagorean theorem equation. This tells us that the net force squared is going to equal the sum, so sum means add, of the square of the 2 sides. So the square of the 2 sides, I'm going to take each side 5 newtons and square it, and I'm going to take 12 newtons and square it. So what I've done here, just to repeat, the net force here, I square that. It equals the sum of the 2 sides squared. So 5 newton is 1 squared, 5 newton is one side, so I square it. 12 newtons is the other side, so I square it, and add them together. Here's what the math looks like. 5 newtons squared is 20 5 newtons squared. 12 newtons, if you square it, is 144 newtons squared. When I add 125, take that back. When I add 25 to 144, I get 169 newtons squared. And this is all still equal to the square of the net force. Now I'm ready to undo the squares. So I'm going to take the square root of both sides. If I take the square root of the net force, I just get net force. If I take the square root of 169, I get 13. And if I take the square root of n squared, newtons squared, I get newtons. So, in this problem, the net force equals 13 newtons. I'll let you figure out that last one down here. And this concludes the video.